All right, guys, so this section is about introduction to graphing, and it kind of has a mix of a bunch of things. We're going to start off pretty easy, stuff you already know, how to graph a point. I'm going to go through that stuff quickly. You already know how to do it. Then we'll spend a little bit more time with kind of the last half of this section that talks about the distance formula. You've probably seen that, but maybe need a little refresher. Midpoint formula, and then equations of circles. So it's kind of a mix of a bunch of stuff in this section. But the first thing I just want to start with is our good old friend, the Cartesian coordinate system, which we know, whoa, sorry about that. Hold on. There we go. I don't know what that did to your screen, but it did some pretty cool stuff to mine. This is our Cartesian coordinate system. Mine is not beautiful, but Cartesian coordinate system. And you know, this is named for the philosopher Rene Descartes. Good old Descartes. Descartes is the guy that said, I think, therefore I am. If you've ever read any Descartes, I tried. I couldn't get really through it. However, I think, therefore I am was kind of interesting because I believe when he's a philosopher and he was like, how do I really know I exist, right? As all philosophers do. How do I really know I exist? And he's decided that like he's not a figment of some alien imagination because he can think. So that's kind of why he said, I think, therefore I am, therefore I exist. There's a little bit of trivia for you someday that'll probably never come in handy. But the Cartesian coordinate system also, if you want to know, there's a story that Descartes was sick in bed and looking up at the tiles of his ceiling and was kind of thinking about a center point, and that center point we call the origin, right? And this is the origin. And he was thinking this fly was moving along the ceiling, and he was thinking, how could he map where that fly is based on some initial point? Who knows if that's a true story or not, but you know, it's mathematics, you guys. We got to try and make it maybe a little more interesting for those common folk out there. Cartesian coordinate system, obviously you know this stuff. We have an x-axis, that's my horizontal axis. I have a y-axis, that's my vertical axis. If you take those two and put it into a plane, it breaks it into 4 quadrants, and I've marked those. First quadrant, and then we go counterclockwise, second, third, and fourth quadrant. We have the origin, of course, and then we know that we can describe where our fly is, right, by any ordered pair. This is called an ordered pair. When you get to calculus 3, good time. We'll have an ordered triple because we'll be in R3. But we have an ordered pair. So remember, x is the horizontal distance. We are from the origin. Again, I'm going to go through this pretty fast because you guys know this. This is my vertical distance, or my vertical units from the origin. So obviously if we, you know, grabbed a couple of these, let me erase a little bit here. So I could look at graphing. See, this is easy so far. You guys are going to be fine. It's just math. I shouldn't say it's just math. Math is amazing and beautiful, and all that is true and right. Whoa, I got to take off my eraser. So if we break up, this is kind of not really great because I'm just kind of hand drawing these tick marks. Of course, they should be all the same, but let's try and graph something here. So if I wanted to graph the point 2, 4, of course I would go over 2 in the x direction and up 4, and then there's my point 2, 4. If I wanted to graph negative 4, 2, right, I would go, oh, I shouldn't have done that because I don't have a negative 4. If I graph negative 1, 2, I'm going to go over 1 and up 2. And so there's my point negative 1, 2. You guys all know this. It's pretty easy. What about negative 3, 0? That I'm going to, again, Sarah, go over 3 right here. And that's my point. I really crack myself up when I do these videos all by myself. And again, in the fourth quadrant, so if you kind of notice, we can see certain things. In the third quadrant, we're going to have all negative values, x and y values. So if I would go over negative 1, down 3, again, that negative tells me to go down. You guys all know this. And then maybe if I had, I don't know, let's do like 4, negative 2. Hopefully you can see that. That color wasn't great. 1, 2, 3, 4. That negative tells me to go down in the y direction. All right, you guys know all that, right? Easy. Easy peasy. So when we're graphing, when we have a relationship between x and y, when we talk about a solution to that relationship between x and y, what we can think of is an ordered pair, and that point would be on the graph of that equation. So for example, if I asked us to talk about a solution to an equation, so let's do a quick example here. Determine if the ordered pair, so let's grab an ordered pair. How about -1, -9 is a solution. So when I say, well, let me write this down. I get a little excited. Is a solution of this equation, y equals 7x minus 2. You guys have seen equations like this before. Remember what this does, though. Don't take this for granted. What this does is it forces a relationship between x and y, right? I plug in an x value that forces y to be something. What does that force y to be? It makes it be 7 times whatever that value is, and then 2 less than that. So what that does is it forces this relationship between x and y. And if I took all the points, right, that made this relationship true and graphed it, it would give me some sort of graph on my Cartesian coordinate system. In this case, it's a line. We're going to talk about parabolas in this class. We're going to talk about the absolute value function. We're going to look at quadratics are parabolas, cubics. We're going to look at logarithms, all that sort of things. So this is kind of really the basis for everything we're doing. So another way of asking, is it a solution? Another thing we could have said is, does -1, -9 lie on the graph? Lay on the graph? I don't care. I'm not an English teacher. Of y equals 7x minus 2. If it does lie on the graph, then it's a solution, and vice versa. So if it's a solution, it lies on the graph. If it's on the graph, it's a solution. If it's not a solution, it doesn't. So how do we determine if that's a solution without actually having to graph that line? Well, you guys all know, right? This is my y. This is my x. So I'm going to put my x in here. I'm going to put my y in here. If we put those numbers in and I get a true statement, then what do you know? It's a solution. Now, I really don't like writing equal signs unless they're actually equal. So I'm going to put a -9, and I don't want to put an equal sign. So I'm going to just kind of put a question mark. I know some mathematicians might not really like that I do that, but you know, that's okay. I have kids that don't like what I do a lot of times, and they'll get over it. So what do I have? I have -9 on the left. Obviously, this right here is -7 minus 2. Does -9 equal -9? Yeah, last time I checked, it does. So what do we know about this point? Yes, it is a solution to the equation, okay? If it's not a solution, what we're going to get, so like, what if it wasn't -1, -9? What about 0, 2? A solution to the same equation, right? Is it a solution? So what's going to go in for y again? I have y equals 7x minus 2. This is the relationship between x and y. I'm going to put in 2 for y. I'm going to do, is that equal to 7 times 0 minus 2? This would imply, is 2 equal to -2? Well, unless something changed over the weekend, I don't think 2 is -2. You either have $2 or you owe me $2. Those are two very, very different things. Wait, yeah, or you owe $2. Do you have $2 and you owe me, you're giving it to me, we're at 0. But I have the 2 does not equal -2. So is this a solution? No. What else does that mean? It does not lie on the graph of this equation. Well, I don't want to say function, I just want to say equation. Okay, that's how we're going to determine if it's a solution. Doesn't always have to be x and y, you know. I could have like, whoa, I meant to grab a different color there. I could have like 4s squared minus t cubed equals 7. And I could look at solutions here. And if I had an ordered pair there, you know, is 1, 3 a solution or not, then we just assume that goes in alphabetical order. So it would be S first and then T. I don't think that's a solution. I don't believe it is. Okay. All right. So that's kind of the stuff that I knew would be pretty easy for you guys. So that's all I'm going to spend on that. This, you know, we could go through and like actually graph some of these lines and make tables, but we're going to spend time graphing later on, you know, with like parabolas and lines and stuff. So I'm not going to worry about that right now. So a couple other things I want to talk about. I want to talk about the distance formula. So there are a couple formulas that are going to be important for you to know and memorize. And the distance formula, my friends, is one of them. Okay, so we're going to have three things you're going to need to memorize in this section: distance formula, midpoint formula, and the equation of a circle. Distance formula is just useful. It's the distance between 2 points. Let's see how we get it. I'm not just going to give you a formula and ask you to memorize it without telling, oh, that was a really bad line. Without telling you where it came from. That'd be silly. You'd be like, Sarah, how can I trust you that this is actually the formula for distance? And I would say, you're right. I need to show you. I need to give you more proof. So let's just take a point in quadrant 1. And a lot of times in mathematics, we say, without loss of generality, let's grab 2 points in the first quadrant. And when we say something like without loss of generality in mathematics, it means I'm going to put these 2 points in the first quadrant. Does this formula only work for points in the first quadrant? No, obviously not. But I don't want to have to show this proof for every single point in every single quadrant. So without loss of generality, let's go ahead and put this in the first quadrant. I'm going to move this. Oh, man, you guys, I used to hate it when my teachers, I would always take my notes in pen, and I used to hate it when my teachers would erase. So now I'm doing it too. Isn't that nice? All right, I have 2 points in the first quadrant. I want to know. Ooh, that was a pretty good, well, that wasn't a great line. Let's see if I can undo that really quick. Sorry, guys. I want to know what is the distance between those 2 points, right? The shortest distance between any 2 points is hypothetically a straight line. That's not a straight line, but pretend. It's going to be a lesson in imagination a bit in my class, because I always have to try and draw things and they don't work. So I need to find this distance right here. Let's get crazy and call this D. So I want to find this distance. How would I find this distance? A lot of times if we want to find distances of straight lines that aren't horizontal or vertical, we always want to put it into a right triangle, because we want to use our good old buddy Pythagoras, right? We remember Pythagoras. And look at what I can do here. If I just draw a straight, I'm going to draw a vertical line down through this point right here. And then I'm going to draw a horizontal line through my other point. And if I just keep going, if you notice, look at how great this is. I have created a right triangle. Isn't that cool? Okay, so if I just grab those two things right there, I've created a right triangle. And the great thing about this is I know these sides. I can find the distance of these sides right here. So for example, this side right here, what would this distance be? Well, if you look at this point right here, and I kind of think of drawing like an imaginary line, what would this whole distance right here, this yellow line, must be y2, by definition of this point being that high from the x-axis. And then if I look at this distance, this point right here, and I kind of draw a line over here, right? And I look at how high that guy is. Oh, I used green, I probably shouldn't have done that. But this distance right here is y1. Okay, so if I want to get the difference between those two, which is this blue part right here, how would I get that difference? How do we find the distance between two things that are in the same, vertically or horizontally? We just subtract them. If I asked you what is the distance between 10 and 6 on the real number line, you would tell me 4. Why would you tell me 4? Because you did 10 minus 6. Ooh, sorry about that. So I'm going to take, to get this distance right here, I'm going to take y2 minus y1. That's just, oh wow, look at what is that right there that I just created? I don't know, you guys, but it's beautiful. I kind of don't want to get rid of it. But I'm going to. Sorry, my hand keeps, telling this. I gotta pull my sleeve up maybe. All right, so I have this distance right here. That's really good because I know I'm going to use Pythagorean identity. So I will do that here in a moment. What about this distance right here? We're going to have kind of the same idea here. I know that right here, I know that right here, this up to here is x2. I know up to here is x1. So I basically want everything in between there. So if I want everything in between there, then I'm going to go ahead and just subtract those. So again, this is going to be x2 minus x1. That's going to be that distance. And you remember Pythagoras, right? A, B, C, a squared plus b squared equals c squared. It's kind of funny when you're a mathematician or a math teacher and you tell people what you do for a living. So I'll be like, yeah, I'm a math teacher, and they'll just shout random math facts that they remember. They're like, oh yeah, a squared plus b squared equals c squared. And I'm like, yeah, it sure does. Still does. It did when you learned it. It still does. So that's one of those facts that always make me laugh. All right, anyway, I'm amusing myself here. Let's see what we're going to do here. So what is my a in this case? My a in this case, right, is the x2 minus x1. I'm going to square that. That's my distance for a. What is my b here? That's y2 minus y1 squared. And then what is my c? My c, or my hypotenuse, is just that distance squared. Now I don't want the square of the distance though, correct? I don't want the square of the distance, so what am I going to do? I'm going to square root both sides. Remember, when you bring in a square root, normally we have to bring in a plus or a minus. However, I challenge you to, go to Home Depot and ask for a negative 4 feet of fencing or whatever you need. Distances, negatives don't really make sense when we're talking about distance. We can talk about negatives maybe when we're talking about displacement or something like that, but we're not going to worry about that. We're just worrying about distance. So here it is. I feel like we should have a drum roll or something. What is the distance formula? It is the square root of the change in your x coordinates squared plus the change in your y coordinates squared. All right, you guys, you've seen this before. This is something we're going to need to know and love and use a lot. So that's my distance formula. Let's go ahead and do an example really quick right here. I know you've already done this. Let's do an example with fractions, because fractions always freak people out. Rightly so. They can be kind of tricky to deal with sometimes. But that's my distance formula. A couple things about the distance formula. We always subtract inside the squared, and then it's always adding those together. Please never distribute the square root across the addition. If you do that, I will be so sad. And you don't want, why would you want to make me sad? You don't want to make me sad. That is every math teacher's super pet peeve, is when you guys break up a square root over addition. It's horrible. Well, I don't know if it's horrible. There are worse things, but all right, find the distance between a couple points here. Let's do some fractions. So I want to do negative 11 thirds, comma, negative 1/2. This is even going to be easy because they already have common denominators. And let's see, 1/3, 5/2. That's too easy. Oh, well, that's okay. We can start easy here. All right, so I want to find this distance. So what do I know? It doesn't matter which one is x1 and y1 and x2 and y2. It doesn't matter. It actually doesn't even matter which one you put first in the formula. You just need to be consistent. You need to keep your x's grouped together, and you need to keep your y's grouped together, okay? So to find this distance, well, the way I have it labeled, I have x2 first, but again, please understand it doesn't really matter. So I have 1/3 minus what? A negative 11 thirds. Don't drop that negative, period, or please, squared plus 5/2 minus a negative 1/2 quantity squared, okay? All right, so what are we going to get here, people? 2 negatives make a positive. Here, 2 negatives make a positive. That, not to be confused with 2 wrongs make a right. Don't do that. So if I add these two here, I'm going to get 12 thirds. If I add these two, I get 6/2. I believe 12 thirds is also known as 4. So I'm going to have 4 squared plus 6/2 is also known as 3. 3 squared. So I have 16 plus 9, which is 25. Oh, look at how pretty that is. Square root of 25 is 5. Doesn't always come out that pretty. You got to pick them pretty carefully for the numbers to be that nice. So we're going to get some square roots with not such nice numbers, like maybe you get something like the square root of 40, then I would like you to please write that. Remember, we can rewrite that as some perfect square factors. I would pick 4 and 10. So this right here would be my distance. If I had something like the square root of 40, this is what we call the exact answer, right? Because the square root of 10 is irrational, goes on forever, never repeats or never ends. So this is what we call the exact answer, or we can throw that sucker in our calculator if we want an approximate answer. So make sure you know what the question is asking. Are we looking for an exact answer, or are we looking for an approximate answer? But I hope that makes sense for the distance formula. It's kind of nice to see a proof of the distance formula and why that is true. That's it. So let's look at, we need one more formula and then we can start talking about circles. I really enjoy circles. I think you'll see I enjoy pretty much, whoops, sorry about that, most things in math. So it probably won't surprise you when I say how much I like certain things. Let's talk about the midpoint formula. All right, you guys, the midpoint formula is exactly what it's sounding like. Without loss of generality, I am going to take 2 points, again, put them in the first quadrant, so I don't have to worry. I'm not going to worry too much. This formula is going to be true even if we were in this second, third, or fourth quadrant. Y1, and we'll call this X2, Y2. And our goal with the midpoint formula, let's see if I can draw kind of a straight line, is to determine, so midpoint, what we want is we want to find a midpoint. I want to find the point that is exactly halfway between, or is equidistant from, the 2 points that I've been given. So the midpoint formula, there's not really like a really big proof to this, but I'll just kind of tell you it. I know I tell you all the time that I shouldn't just tell you things, but the way I'm going to get this is I basically want to be halfway between. So how do I find, like if I asked you what is halfway between 10 and 20, you obviously would tell me 15 because you can just think about that. But how do we get the 15? Well, if you take 10 plus 20 and divide by 2, right, that's 30 divided by 2 is 15. So it's kind of like taking an average, and that's kind of where our midpoint formula comes from. So our midpoint formula then, the midpoint between 2 points, x1, y1, and x2, y2, is going to be given by, I'm going to add my x coordinates and divide by 2. What that does for me is it takes me, I guess I am kind of doing the proof then, is it actually gives me that mid distance between x2, x1 and x2, right? That's what I want. This guy right here is going to be x1 plus x2. That's how I find halfway between two things. Add them up and divide by 2. And then likewise, it's going to be the same for y. So I want you to remember that midpoint, if I ask you to find the midpoint of something, that means I'm asking you for a point, hence the name midpoint. If I'm asking for distance formula, that's what you're just going to get a number out. Midpoint formula is going to actually give me an order to pair. I hope that makes sense. Whoa, did not mean to do that. Whoops, there we go. Okay, so let's look at a quick example. These are pretty easy, relatively easy, I think. Let's do another one with fractions because in my experience, those are the ones that trip people up. Totally understandable. Find the midpoint. And then let me write this out. I like to just say between 2 lines or 2 points, but that's not technically how we should say it. We should say find the midpoint of the segment. Let's get kind of technical here. So the line segment, right? Having the given endpoints. Because if we're talking about halfway between something, what we're really saying is we want to be equidistant. And so that means we need to have an actual line. So find the midpoint of the segment having the endpoints. I said I wanted to do some fractions. Let's do them. -1/6, comma, -3/5, and -2/3. Ooh, this is gonna be fun. 5/4. I love doing fractions. All right. Let's do this. So my midpoint, what I'm going to do, I'm going to be very careful, especially because I'm adding fractions and I have another fraction. I have a complex fraction. We're going to get complex here. I'm going to have 1/6 plus, don't forget your negatives, a -2/3. You could, of course, write that as a -1/6 minus 2/3, right? This is all divided by 2, comma, -3/5. And then what, plus, remember midpoint is addition also. That's a little tricky when you're dealing with, you know, the distance formula and the midpoint formula in the same section. just remember that the midpoint is always addition. I always try and remember it as it's an average, and when we find averages of things, we add it up. All right, people, let's get some common denominators in here. What do we got? We have 6 and 3, so the common denominator is 6, right? That's the smallest number they both divide into. So I'm going to multiply this guy by 2 over 2. 5 and 4, they don't have any common factors, so this guy's going to have a 5 and a 5. That guy's going to have a 4 and a 4. And you're like, Sarah, I've already done this on my calculator or my phone. And I'm like, well, then you have deprived yourself of true joy in finding fractions. I'm going to make this a minus now, so I have 4, 6. Hope that's right. You know, it's tough when you do these videos and you don't have your students to point out blatantly to you all of your arithmetic mistakes that you constantly make. Look at how nice I'm keeping. Now I'm getting kind of squished on the screen here, but look at how nice I'm keeping everything nice and organized. I'm not dropping that too. I'm making sure my line comes all the way over so that I don't confuse myself with what's actually happening here. And I'm going to have to move up here. Let's see. Let me get rid of some of this stuff up here and we'll finish it. So one thing about becoming a good mathematician or becoming good at math is just really half the battle sometimes is just making sure that you are organized, making sure that what you're writing down is true mathematically and so you don't confuse yourself. All right, so this first one right here, it looks like we're going to have, whoops. Sorry about that. I kind of messed up my ink, my brush size here. Maybe a little bit bigger than that. We're going to have a negative 5, 6. Sorry, guys. Negative 5, 6 over 2. And then here, 12, 25 minus 12, I think it's 13. So I'm going to have 13 over 20 all over 2. Now, if this is starting to freak you out because of these complex fractions, totally understand. What is this the same as? This is the same as 1/2 times negative 5, 6, right? Look at what you're doing, people. You're just dividing by 2. You're taking half of something. And 1/2 times 13 over 20. So I don't like to memorize a bunch of rules. What I like to do is kind of just think about what does it mean to divide? It means to multiply it by the reciprocal of whatever that number is, right? So the reciprocal of 2 is 1/2. And so what is our final answer? The midpoint of a line segment here looks like it's a negative 5/12, right? And then what do we have here? 13/40. Remember with fractions, you just multiply straight across. It's the easiest thing we do with fractions, multiplication. There's my midpoint. Bam, you got it. All right, distance formula, midpoint formula. Those are important formulas to know from memory. And why those are going to be important? Well, we'll use them quite a bit with different things. You'll use them if you go on in mathematics all the time. Distance formula probably more than the midpoint formula. But one reason it's going to be that was a little crazy. Interesting for us right now is we are going to talk about circles. And we're going to need, I always do that. We're going to need both of these to look at some interesting examples for circles. Okay. So in my face-to-face classes, what I love to ask at the very beginning of this is I say, what is a circle? And everyone could draw me a circle, of course. But what is a circle like, right? What does it mean for something to be a circle? And the idea is a circle just consists of all of these points that are the same distance from the center. That's really what a circle is if you think about it, right? Circles are amazing things in mathematics, and they do, pi is involved with circles later on, and pi is just an amazing number. So, okay, now listen. That was not a line. What I am going to draw right now is not going to be a circle because I, for the life of me, cannot draw circles. I've been teaching for quite a while. I can't draw them. So this is a bit of a test of your imagination. All right, so we're going to have some sort of circle. Again, what I kind of had alluded to before is that what is a circle? A circle consists of the center. So I'm going to call the center of my circle here. Again, with that loss of generality, I'm going to put this guy in the first quadrant. And I'm going to call my circle HK. And I actually want my H and my K. Sorry, guys. I want my H and my K to be over on this side. Sorry for those of you taking notes. Hopefully all of you are taking notes. And now what I'm going to do is I'm going to take all the points. So I'm given some point here. And what my circle is going to consist of is all of these points, right, that I have decided are a certain distance away from that center. Okay, so I'm going to actually go a little closer so I don't have to draw. Oh man. Oh, you guys. This is embarrassing. Can I try that one more time? It's just kind of tough on my computer screen here. Let's see if I can do this a little bit better. I'm actually a little bit better on like a chalkboard or a whiteboard, but apparently on this thing I just am absolutely horrible. But I would love to come and see what your guys' circles look like on in your notes. Okay, so anyway, here's my circle. Again, if you think about this, pretend it's a circle. Pretend that all of these points on this green curve right here, right, are all the same distance from the center of the circle. And now, again, remember what an equation does. An equation forces a relationship between x and y to guarantee that all the points on that graph satisfy that relationship. So what I want to do is I want to bring up some equation that thinks about every single point on the circumference of that circle and relates it somehow to the center of that circle. So what, again, without loss of generality, I'm just going to grab some point on my circle and I'm going to call it xy because I want that point. I don't want to give it an actual number. I don't want to say x1, y1 or x2, y2 because I want it to represent any point on that circle. So that x and that y value represent any point on the circle. And I got to figure out how to get this x and this y to be related to not only the center of the circle, but what else do we need to care about? That distance from the center of the circle to any point on the circle. And we haven't really talked about what that is right now, and we're going to call that distance r. Whenever you mess up, you just make your point a little bit bigger, and then it looks like you're good to go. So there are kind of three things we're going to look at. The center of the circle, I need to relate that somehow. The radius of the circle, you guys have probably heard radius. That's a distance from the center of the circle to any point on the circumference. And then, of course, whatever that point is on the circle. So I'm going to use that same trick that I use. This is so cool. Watch, you guys. This is so cool. I'm going to use that same trick that I used when I did the distance formula. I'm going to draw a vertical line down through this point here, and then I'm going to draw a vertical line, that's a horizontal line through this point here. And what do you know? My good old buddy Pythagoras is back, right? I got Pythagoras back. Or his followers, right? Because he probably didn't actually come up with the Pythagorean theorem, but like his little school of mathematicians did. I'm going to do the same thing here, you guys. I'm going to figure out what is this distance right here. Well, how high is this point? This point is y, right? And how high is the point, like how far would I come down to this right here? Well, this blue point right here has the same height as my center. What is the height of my center? It's k. So if I want that distance right there, that distance right there is y minus k. I hope that makes sense from our discussion with the distance formula. Same thing here if I look at a horizontal distance, right? The horizontal, how far over is this blue point right here? Well, how far over is that blue point is the same as x. How far over is this point right here? That would be the x value of my center, which is h. So here we go. We're almost here. Here's my formula for a circle then. I have a right triangle. I have this distance, and of course my hypotenuse. And I can relate those by taking x minus h, quantity squared, plus y minus k, quantity squared equals r squared. Again, I really think I'm going to need to get some music to add, or a drum roll or something, and then cheering once we get the formula. You guys, the formula of a circle, I know it kind of looks intense, and that some of my students are like, oh my gosh, that's crazy. It's just the distance formula. That's all it's doing. It is forcing the distance between any point on the circle, which is represented by x and y, and any center point, h and k here, right? That's my center point. That's fixed. It's forcing that distance between any point on my circle and the center to be that r, my radius. That's the definition of a circle. Isn't that cool? I love doing these. I love circles. I think they're so fun. Okay, that doesn't surprise you because I probably have said everything is fun so far. Let's do some examples. Find the equation of a circle. Of a circle with center. All right, what is my center? Let's do center 2, -1, and radius, and then we'll graph it too, just for giggles, and radius 3. Okay, all right, so here's the thing with this circle. This x here and this y here have to stay x and y. Now, there are different ways you can do this, right? And if you have a different way sometimes of figuring these things out, you can use it as long as it's mathematically valid. I'm good with that. But that x and y are going to stay x and y because those guys have to represent every point on the circle. What is going to be replaced with numbers are the h, k, and r because those are set. Those are fixed numbers for my circle. So I'm going to take x minus the y coordinate of my center, which in this case is 2, quantity squared, plus y minus a -1, so that actually becomes +1. Quantity squared, you guys know that, right? Y minus a -1, so that'll become +1, equals 3 squared, which is 9. There you go, you guys. That's it. There's the equation of my circle. Any point on the circle will satisfy, right? Will satisfy this equation right here. It has to, based on the definition of this circle. Likewise, any ordered pair that I can find that satisfies this equation right here is guaranteed to be on my circle. If I wanted to graph this guy, so let's see if we can graph this. 1, 2, 3, 4, 5. I like to count to myself, apparently. Okay, so if I wanted to graph this circle, what I want to do is graph the center. So I'm going to go over 2, down 1. So there's my 2, -1. And then it's tough because we want to find a couple points so we can kind of sketch the circle in. So you just want to take, we know we have a radius of 3. Just go vertically and horizontally because those are really the only ones that you can for sure get a radius of 3. So I'm going to go to the right 3 units. 1, 2, 3. I know that point must be on my circle. I'm going to go down 3 from the center. I'm going to go up 3 from the center. And I'm going to go to the left 3 from the center. I'm going to connect the dots. La 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 la. Oh, you guys. Oh, it's just so bad. This circle is just so bad. It's not even a circle. Anyway, and what I like to do with these, because I think it's kind of fun, is I like to see, like, look at, what do we have here, you guys? We have this point, 1, -1 that we say is on the circle. If we put that into this equation here, people, it better work. It better work. So if I put in the 1, I'm going to get 1 minus 2. I'm going to get -1 squared. I need those parentheses around the negative. Don't you dare drop those parentheses. And then if I put in the -1 here, oh, this isn't going to work. What did I do wrong? 1, 2, 3, 1, 1. Oh, you guys. I bet you're yelling at the screen right now. I'm going to do something here. I'm going to make this a -2. I graphed -2, -1, didn't I? Oh man, that is so embarrassing. That's all right. It's just on YouTube for everyone to see forever. I'm not worried about it. Sorry about that. Can I just change that a little bit? Just change it in your notes. I don't want to have to grab a whole new picture. I graphed -2, -1 instead of 2, -1. Let's do -2, -1, which would make my equation y plus 2, y plus 1. And now we're going to see, hey, but look at, this was an excellent teaching moment because as you could see, when I went to check if 1, -1 was a solution to my equation, I realized it wasn't a solution. So what must have happened? I'm pretty sure my equation was correct. So I went back, I looked at how I graphed it. It looks like I graphed it wrong. So while I didn't mean to do that, this is a great teaching moment of how you can always check yourself. So if I had done it correctly, and that was actually a -2, look at what we're going to get here. We're going to get 1, whoops. We're going to get 1 plus 2, which is obviously 3 squared, plus -1 plus 1, which is 0 squared. Sure enough, that equals 9. So this is a good example of how checking your solutions into your equation can kind of help you see maybe if you went wrong somewhere. let me just do like 2 more, and then I'm going to call it good because I've been talking for a long time. A little bit worried that you guys are not with me anymore, which would be understandable. But if you need to, pause me, right? Unlike my husband or my children, they can't pause me. You can pause me, take a break from me, and then come back. How about something like this? Find the equation of a circle with, what do I want to say here? With points, let's do, oh, whoops, sorry about that. With points 7, 13, and -3, -11 at the ends of the diameter. Okay, so this is going to probably be one of the more difficult ones we will do. And this will be the last one I do for you today. So what I like to do here, now 7, 13, I don't really want to graph. -3, -11, I don't really want to graph. But what I could do is just make a quick sketch to see what do I have going on here. So let's say like 7, 13 is maybe up there, and maybe -3, -11 is down here. So what I know is I know that these points are on the end of my diameter. So I know that I must have, pretend that's a circle, people. It's a lesson in imagination. Pretend this is a circle. I know that I have some circle going through there where, remember, these 2 points here are on the end of my diameter. Remember what you need to find a circle. You need your radius, right? What were the 2 things we needed? My R and my HK, which were my center. So I need a couple things here. I need the distance of my radius, and I need my center. There are a couple ways you can go through this, you guys. I think the easiest way, is to find your center first, and then you can either go use the distance formula if you want, or we can actually just use the equation of the circle and figure out what my radius is. So let's go through and do this. Let's find our center first. How are we going to find our center? Well, we know our center is halfway between the endpoints of my diameter. Midpoint formula. Yay! So I'm going to use my midpoint formula. Here we go, you guys. It's going to be awesome. I'm going to do 7 plus -3, so that's 7 minus 3 over 2. I'm going to do 13 plus -11, which just becomes 13 minus 11. So what is my midpoint then? 4 over 2, which is 2. And then I have 2 over 2, which is 1. Okay, so look at this. We're actually almost done. Now, when I have taught this in the past, I think I get my mind so focused on the distance formula that I feel we always have to use the distance formula. But I've had students show me, well, why can't we just do this, Sarah? And a lot of times you students, you're quick, right? You're quick. You see things maybe that people like me who have been doing math for a really long time don't always see. That's good. That's important. So look at what I have here. I have taken my center to one that looks about right in my equation. I mean, I didn't draw this perfectly or my graph here, but it looks like it should be in the first quadrant, so I feel comfortable with that being 2, 1. This is my equation so far. What is the only thing we're missing? We're just missing this R. Now, you could take your distance formula, right, and find the distance between 2, 1, maybe, and your 7, 13, or find the distance between 2, 1 and -3, -11, or find the distance between your 2 endpoints of diameter and divide by 2. Lots of ways you can do it. Or remember, you guys, remember, these points right here must satisfy this equation because they lie on the circle. So what I'm actually going to do is I'm just going to plug in the 7 right here for my x, and I'm going to plug in the 13. Why did I use 7 and 13? I don't know. Just because they were the first ones and they didn't have negatives. So I usually make negative errors or sign errors, so I just try to avoid them. Could I have used -3, -11? Obviously you could have, because it's on the circle. So what do we get here? We get 5 squared plus what? 12 squared equals R squared. So look at what this is saying then. 25 plus 144. It's saying that R squared is 169. And that's actually what I want. I want R squared. Now, could I square root it and say that my radius is 13. Absolutely. But then notice you're just going to be squaring it when you put it back into your final answer. But that is fine. I mean, you would need that radius if you were going to graph this. So my final answer then, you guys, the equation of the circle with those given endpoints of my diameter is this right here. Remember what that equation does? It relates each ordered pair to lie on that circle. X minus 2 quantity squared plus y minus 1 quantity squared equals 169. That was really fun. Let me know if you have any questions.